Hello, this is Mrs. Heisemuttle, and today we're going to talk about VEX Robotics Safety Guide for my GTT 8th grade VEX Robotics class. So, general safety rules: always wear your safety glasses to protect your eyes. Normal glasses are not made of impact-resistant plastic. They do not give you enough protection if something were to break and come flying off of your robot. Always wear closed-toed shoes to protect your feet. Heavy objects or sharp objects which can be dropped on your foot are going to do more damage if you're not wearing a good shoe. You need a closed-toed shoe to protect your feet. Avoid wearing loose-fitting clothing. It can become caught on the equipment and pull it off the table, or it can get torn. You could end up getting hurt. Lots of bad things can happen. If you have a big sweatshirt on, just push your sleeves up and you should be fine. If you have long hair, try and keep it tied back to avoid it becoming caught in any of the moving parts that we're dealing with. And this essentially also is true. Just don't lean over your project and you should be fine. Unless your hair is super, super long, it's probably okay as long as you just pull it back. No horseplay. We absolutely positively will not have any. Something's going to get broken if you are playing around and pushing and shoving each other in this class. Safety glasses. This deserves an entire slide all to itself. They're built from scratch and impact resistant plastic. They provide increased protection. Little plastic and metal parts do pop loose from a robot occasionally, and you definitely don't want that to hit you in the eye. Don't take your safety glasses off or flip them up on top of your head or take them off your eyes in any way until you have left the work area. Don't forget to put glasses back on when you're entering or returning into the work area, like if you got called to the office or whatever. Structure and motion. The kit contains a lot of metal parts. If you cut them or bend them, you can cause them to break and you'll end up with a lot of sharp edges, so be very careful about that. The kit also contains a lot of small plastic parts and screws. Please don't ingest them, i.e. don't stick them up your nose or swallow them. They are not made for doing that and you're going to make yourself very sick. When your system is powered, keep your fingers, tools, hair, and everything else away from the gears and wheels. Those little plastic parts may look like they're not going to do a lot of damage, but they can pinch and cut and really hurt you if you're not careful. So make sure your hands are away from the robot when you power it on. Okay, power and batteries. Don't lick your batteries. I know there are people out there who think this is hilarious to lick the top of the battery. Oh gee, I'll get a little shock and see if it's charged. Yeah, leave it alone. Don't do that to my batteries. They're not that kind of battery and you're going to get more than you bargained for. Plus, I don't want your mouth on my batteries. Batteries are for use in this class only. You can't take them and go use them for something else. They're not made for that and they're specific for our robotics kits. Don't run a wire from one end of the battery to the other. You're going to make it overheat and you could damage you and the battery. If a battery appears to be leaking or it has some crystalline deposit on the outside, dispose of it as directed by your teacher. Do wear gloves. Come and get me. I will put on gloves or I will give you gloves to wear. That's battery acid that's coming out of there and it's going to be bad for your skin, definitely. You can't throw batteries into the trash, especially rechargeable batteries. They have to be disposed of as hazardous waste. This is actually true of all batteries, even the ones you have at your house. You're not supposed to just throw them in the trash. They need to be recycled or disposed of correctly. If you have any questions about that, you can ask me and I will show you how to do that. If you break it, you buy it. Parts for the VEX kits are really expensive. A motor, which can be easily broken by over-tightening the screws, the little motor mount screws, costs between $19. It costs around $19 or $20 and then you have to ship it. So other parts are equally expensive. The Cortex, which is the robot brain, it costs about $249. So then you have to pay for the shipping to replace it. So make sure you are not breaking that. That is the most expensive part of the box. You really don't want to break them. It doesn't mean you can't use them. You just don't want to be screwing around with them. Now, there are lots of different kinds of screws in your box, and they're different, and yes, it matters. We have an 832 screw with a button head. You can use a standard 3/32 ball end driver or the Vex Allen drives on these. They're made of high strength stainless steel. They come in various lengths. In our case, they're all black. These are used for most of your assembly parts, connecting things together. They are larger than a motor mount screw, and that's how you can tell them apart. A motor mount screw is also called a 632 screw with a button head. You can use a 5/64 drive or a Vex Allen wrench on these. These are made for motors and servos only. They're smaller than the regular screws, and they are used only for very specific things. You don't have very many of these in your kit because you don't need very many. You only use them for the motors. Now, the drivers, we have a bunch of different kinds. There are 3 kinds of screwdrivers in your kit. You have a ball end driver, which works on the 832 screws with the button head. You have the 5/64 driver for the motor mount screws, which are the 632 screws with button heads, and the shaft collars also use the 5/64s. You also have a 3/32, which works on regular screws. It's not the best driver for that because it is a button end and this is an Allen end, but it will still work. You also have open-ended wrench and an Allen wrench in your kit. Nuts and collars. Kep's nuts are these nuts. They have external teeth which basically work as a lock washer. You use them on the 832 regular sized button head screws. This is a shaft collar. It fits on the axle of the shaft to lock it in place, and you use a 5/64 to turn the little screw there to tighten it down. This is a nylock nut, and these have an internal nylon lock. They are used only on the 632 motor mount screws. You cannot use these on the 832s. They will lock into place and you will never get them off. Bearings. The standard bearing is the bearing flat mount, which goes directly on a piece of metal and helps support things, and you can run your axles through them and all sorts of other stuff. They mount with either screws with Kep's nuts on the back, or you can use the little plastic pop rivets like in the picture, and that will allow you to snap them in. The pop rivets go in from the back and hold that into place. They're a little faster than using screws. This is a pillow block bearing. That's the one that has the pillow or the raised little piece. It's used to support a shaft, which is offset. It basically keeps your long axles from leaning to one side or another. The lock bars, however, fit onto a shaft and basically lock it in place so that you can then screw the lock bar onto a piece of metal, and the entire piece of metal will turn along with the shaft. Now, limit and bump switches. You have both in your kit. You get a pair of simple limit switch sensors, which basically they're used for when the microcontroller basically touch them and they turn something on or off. These switches are great for signaling when a robot arm has reached the top or the bottom of a motion. The kit also includes a pair of simple bumper switches. These are real simple. You just press them to turn something on or to turn something off. Line trackers and potentiometers. Program your robot to follow a black line on a white surface. That's what your line trackers do. Your kit provides more design flexibility. You can also use it to program your robot for light sensing. When it's dark, this turns on. When it's light, this turns on, kind of thing. With the potentiometer, you can determine both the position and the direction of the rotation, so an axle fits through the center part of that potentiometer, and you can either use it as a turn so that it turns around, like I'm thinking one of those light switches that you turn to make things dimmer or brighter. You can do that, or you can attach it to the motor and the potentiometer will send a signal to turn the motor off when it reaches a certain point in its turn. So the measurement can help to understand the position of robot arms and other mechanisms. So that is our basic robotic safety. And now you are ready for your quiz on QuizStar all about robotics.